All right, we're back. We're on page 9 of Calc C Notes 2, and what we're going to do is answer these questions, I guess. So we're given a function, we're going to write a polynomial, we're going to evaluate the polynomial at a certain point to approximate a value. We'll determine the maximum possible error, state the range of possible answers, use a calculator, it's all calculators. So you could either have memorized this at this point, you could make a table of values and then use the formula that you memorized. Or you could use your calculator. I'm going to end up using a calculator anyway, but just to point out that you should have it memorized, I'm going to write this from memory, hopefully. So it's 1 minus, so I know cosine's an even function, so it just has all of the even powers over their respective factorials. And then it also will alternate. So I know that, and you should know that one by memory. Like get that in your head and never lose it. So evaluate your polynomial. So what we're going to be doing here is we're just going to be doing p of 0.7. Now, as far as the AP exam is concerned, we could say p of 0.7 is 1 minus 0.7 squared over 2 factorial plus 0.7 to the 4th over 4 factorial and live our life. The problem with that, I think, is part D when it says state the range of possible answers. What are you going to do? You basically need decimals at some point. So I'm going to switch over to the calculator and see if I can get that rolling. So let's see. All right, so I'm going to start a new document. I'm on document 15, you might notice. That's not unusual. I usually go into the 20s before I delete. I'll close all of them and then restart the calculator just to avoid potential problems. So I could do menu 4C1 is Taylor polynomial, but I'm just going to type Taylor. Cosine of x, comma x, and then I want, so I want 3 non-zero terms. It's not really enough to say 3 here, which will try to give me the 3rd degree polynomial. The 3rd degree polynomial is the same as the 2nd degree polynomial, so this will only give me this. I need to go up to 4 because I want 3 non-zero terms. And what it did was it made 4 factorial into 24. There's nothing you can do about that. It will always do that. And so I'm going to set p of x equal to this, and then ask the calculator what it thinks p of 0.7 is. I'm going to write that to 3 decimals. 3 decimals doesn't always work on these because it's often not enough. So p of 0.7 is approximately 0.765. All right, maximum possible error. Now, to get, there's a tricky issue that I'm going to maybe actually gloss over here. To get the polynomial that we're looking at, we had to use up to the 4th derivative. So we need to use the 5th derivative to figure out what m is, right? So use the 4th derivative to get p of x, need 5th derivative to get m. So I need the 5th derivative of cosine, which I'm more than happy to let the calculator work out. I mean, I know it's periodic, but it's I don't know, negative sign. Okay, so the maximum possible error, I'm going to switch back to, so I can write this down here. The maximum possible error, so m, the value of m that we're going to use, I go back and forth on this because maybe I need to expand my definition of m so that it encompasses what we actually end up doing. But I'm going to say that m is the maximum. Now, it's centered at 0 and we're approximating 0.7. So it's going to be the maximum on 0 to 0.7 of the absolute value of the 5th derivative. Right? Now, this value is, so this is the, all right, it's the maximum on 0 to 0.7 of the absolute value of negative sine of x, because that's the 5th derivative. So basically, what's the maximum of sine on 0 to 0.7? Well, I don't know. I mean, it's sine of 0.7 is the maximum, but that's rough to use. So what I'm going to say is this is definitely just less than or equal to 1. So that's what I'm going to use. This is my value that I'm using for m. So then the absolute value of the error is less than or equal to m, which is 1, and then times the absolute value of 0.7 minus 0. So 0.7 is because that's what we're plugging in, to the 5th power over 5 factorial. I wish that hold on, let me use a different color for my absolute value symbols because they look like ones. So we get this. This is the maximum possible error. I'm gonna use a calculator to get that. I mean, the exact value is 0.7 to the 5th over 5 factorial. I'm gonna use a calculator to get this though. And then the next thing we're gonna do, state the range of possible answers. So the range, let me just deal with that now. The range of possible answers, the actual value, so it's our approximation, which is P of 0.7, minus E, let's call this E, capital E, is definitely less than or equal to F of 0.7, which is less than or equal to our approximation plus E. So what we're saying is that our approximation is whatever it is, and we can go E in this direction, we can go E in this direction, the error in this direction, or the error in this direction. That's what we're saying. So this I'm like 100% confident is going to give us an interval that works. I mentioned in a previous video that if you get the error horribly wrong, but you're way bigger, then it's still going to tell you true because you're using the wrong thing. So let's see. I want to do. I guess I'll actually like store that 0.7 to the 5th over 5 factorial is that, and I'm going to store that as a right? So that's actually what I usually store it as. So I'm saying that 0.7 minus is, so I'm just handwriting this while I'm here, 0.764 less than or equal to F of 0.7 less than or equal to, now we got to add it, but you don't have to type it again, just paste it down and change to a plus. This 0.766, so 0.766. So the actual value should be, so F of, did I store F? F of X is cosine. So the cosine of 0.7 should be in between 0.764 and 0.766. Should be in between those. So actually, because of rounding, like 0.766 is actually smaller than 0.7664. So depending on how you're doing the problems, you could actually like get false here because maybe cosine of 0.7 is actually 0.7661, right? So like that would work. So the 3 decimal round, it will never happen on the AP exam because they're very careful about it. It might happen on a problem that I write because I am not careful about it. But the actual value could potentially fall outside of the interval that we wrote, 0.7648. So it's definitely inside there. So if we check, this less than or equal to F of 0.7 less than or equal to this should just say true. And it does, because we got it. All right, so approximate the actual value. The actual value was, so the cosine of 0.7 is approximately 0.765. And then the next question is, if the calculator approximation isn't in the range of possible answers, start over. But it was, so I'm just going to say it was. Oh, and that's the whole thing. Interesting. Okay. So we got it right. Let me go back to the notes. Feels like an abrupt place to stop, but I also think it's probably a good place to stop. I might break this up and just do like one problem per video for these particular things because, it gives you a chance. I don't know why I would do that. They're kind of long, basically. But that's the process, right? So finding M is the weirdest part. Once you find M, everything is just like gonna go. So I'll end this here, come back in the next one, do the next problem. Hope to see you there. And I hope these are working for you. So see you there.